Today we're going to be learning about the Cartesian plane and how to draw lines on the Cartesian plane. Now when we look at the Cartesian plane, it's kind of like thinking about a map, but instead of, as you can see in this picture, different types of maps with different scales and ways of looking at them, the Cartesian plane kind of keeps things standardized. So we're going to learn proper terminology to keep it standardized and then how we could actually graph a line on there. So first of all, I'm going to go to our note and we're going to work through it together. So you'll see it says a Cartesian plane is a grid, and that's over here, with a horizontal axis and a vertical axis. Horizontal means like the horizon, going back and forth that way. Vertical means up and down, going this way. So there's the horizontal axis, the x-axis we call it, and there's the vertical axis, the y-axis. The axis is divided into 4 quadrants, and it's numbered kind of in an odd way. You would think it'd go clockwise, but it actually goes counterclockwise. So we've got coordinate 1, the first one here, the second one over here, the third, and then the fourth. So coordinate 1, 2, 3, and 4. The point where the axes intersect, so if you look at the two axes that we talked about, they meet up at a point right here. And that point is called the origin. Now, I often like to tell people to think about superheroes and how they always have an origin story. And an origin is like the beginning of how that superhero got their special power, how they got to be able to see through things or fly or whatever. And that comes in the origin story, the beginning of their journey. So this is called the origin right here on our Cartesian plane. And if we were to label it, it would be at point, sorry, I'm just going to erase this here, 0, 0. So there's the origin. An ordered pair identifies any coordinates on the graph and is written in the form x, y. So the x value of the coordinate is always written first. That means the first number is telling you how far you're going to go back and forth this way. The y value of the coordinate is always written second, and the y value is telling you how much you're going up or down. All right, so let's kind of try this out down here. If we were going to graph some of these points on the plane, point A would be at an x value of 2 and a y value of 5. So for the x value, we're thinking of going back and forth. So we go over 2, and then for the 5, we go up 5. 1, 2, 3, 4, 5. So we're right over here at 5. So if we go over 2 and up 5, the point where that would be is right here. For B, we're going to go back 5 and up 5. So start at the origin, go back 5. 1, 2, 3, 4, 5, and then go up 5. 1, 2, 3, 4, 5. So we're going to be right here for B. For C, it says 0, 4. So we don't go over any, we don't go back any, we stay right at 0. And then we're going to go up 4. 1, 2, 3, 4. All right, so that's where C is. Okay. You can refer to the note to see the rest of the examples and check them. I'm going to move on to down below the next set here. So it says identify the coordinates of each point shown on the graph. So A right here, they want us to give the x and the y value. So let's look and see how far over we're going with our x values. If we start at the origin and we want to get over here to A, we're going back 1, 2, 3, 4, 5, 6 points. So we've gone back, oh, I counted 1 too many. Sorry, let's do that again. 1, 2, 3, 4, 5. We only went back 5. So we're going back 5. And how far down do we go to get to A? Well, we're at 0 here, and then we're going down 2. So we've gone down 2. So the coordinates for A are -5 and -2. Okay. When we look at B, the coordinates for B would be we're going to do the x value first. So we start at the origin and we go over 1, 2, 3, 4. So it's at 4. And then we're going to go up 1, 2, 3. All right, so that's the coordinates for B. So you can get the rest of these. The completed note is going to be posted, so you can fill them in. Okay, now on the next page it says all lines, circles, curves, etc. that can be drawn on the grid have an equation with an x and a y variable. One way to draw the graph for the equation is to create a table of values. So that's basically just like a chart, and what the chart does is it's going to give you the x and the y pairs that are a part of this relationship. So I want to go down here and work through an example with you. So this line says y equals x. So they're saying y is going to be equals whatever x is. So if x is -6, the y value is -6. If y equals x, then if y is 0, x is equal to it, so it has to be 0. If x equals 5, then y has to equal 5 based on this. And if y is 7, then x has to equal 7. So here's our chart. -6, -6, 0 and 0, 5 and 5, 7 and 7. So after we figured out the chart or the table of values, we want to plot those points onto the grid. So if x is -6, y is -6. So we're going to count back 6. 1, 2, 3, 4, 5, 6, and up 6. 1, 2, 3, 4, 5, 6. Okay, so I'm going to show you where it came from and then delete it because it's going to make it really messy. So back, oh, I guess it was said down 6. Sorry, I missed that. So we're going to go back 6 and we're going to actually go down 6, not up 6. So there we go, that's our first point. Then our next point is 0 and 0. So we go to the point 0, 0 and place a dot there. The next one is 5 and 5, so we go over to 5 and up 5. And then last we go to 7 and 7, so it's right here. All right, once we've plotted a bunch of points, we're going to join them with a straight line. You should always use a ruler. You want to fill the grid right up completely. You're going to draw a line at either end to show that it continues, and you can even label it y equals x. Okay, now at the very beginning, when I was doing this example, I made a mistake and I had counted back 6 and up 6. And that's actually a good thing for some learning here to point out. If you plot a bunch of points and they're all lining up and making a nice straight line like this in a linear relationship, and you see that there's one point that's way off, usually what that means is that you've made some sort of mistake. You've dropped a negative sign, or like in my case, you went up instead of going down 6. So when you go to plot using a table of values, if all your points are lining up or most are lining up and you've got one that's way out there, you know you've probably made a mistake, and you can go back and check your algebra and see what you did. All right, so I'm going to move on to the next example here. Example 2 says y equals x minus 3. So y is whatever x was minus 3. So let's fill in our chart. If we want to find out the y value when x is -4, well, we've got up here y is -4 minus 3. So the y value is going to be -7. Down here, when x is 0, we'll go back up to our equation again. Y is x 0 minus 3. So y is -3. When x is 1, 1 minus 3 is going to give us -2. And then when x is 5, or when x is 5, y is 5 minus 3, so 2. So let's plot these points. When x is -4, y is -7. So I'm going to go back 4, and I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, right there. When x is 0, y is negative 3. When x is 1, y is negative 2. When x is 5, y is positive 2. So I'm going to plot all those points on, and then I'm going to draw a straight line through them. This is showing the relationship. I'm going to draw an arrow on either end, and I'm going to write y equals x minus 3. That's the line that we've drawn here. So whatever value we pick for x, the y value will be that x value minus 3. All right, let's look at this one. This one says, let's pick a different color here, orange. Y equals 4x. So y is going to be equal to 4 times the x value that we have. So here, if x is negative 1, y is going to be 4 times negative 1. So that's going to give us negative 4. And then down here, we've got y equals 4 times 0. So that gives us 0. Y equals 4 times 1. So that'll give us 4. And y equals 4 times 2. So that'll give us 8. So we can graph those points. When x is negative 1, y is negative 4. When x is 0, y is 0. When x is 1, y is 4. When x is 2, y is 8. So we're going to draw a line through those points. Nice straight line, use a ruler. Put an arrow on either end and label it y equals 4x. All right. The next one I want to look at here says y equals negative x minus 3. So we're going to do the same thing. If x is negative 6, what's y? Well, y is going to be, so we've got to follow this really carefully, negative x, so x is negative 6, minus 3. So we've got minus 6 minus 3. So that's going to become 6 minus 3, which will be 3. So that's our y value. Here, when x is minus 4, we've got y equals minus 4 plus 3. So we've got minus 4 plus 3. Oh, minus 3, sorry. So we've got 4 minus 3. So that's going to give us 1. Then we've got x is 2. So when y is equal to negative x minus 3, we come back up here. Y equals negative 2 minus 3, which is going to give us negative 5. And then we've got 4. Y equals negative 4 minus 3, which is negative 7. So let's plot those points. When x is negative 6, y is 3. When x is negative 4, y is 1. When x is 2, y is negative 5. When x is 4, y is negative 7. We're going to connect those points with a straight line. Draw a line on either side and label it y equals negative x minus 3. All right. Over here with this example, now we have a fraction in front of it. So what we have is y equals half of x plus 5. So you'll notice that here, the values that were chosen were all numbers that could easily be divided by 2. You can choose any numbers you want. You can have decimals on your in your equation, but usually we like to pick numbers that aren't going to give us weird decimals. So negative 6 is our x value, so y equals half of negative 6 plus 5. So y equals 1/2 of negative 6 plus 5. So half of negative 6 is negative 3. Negative 3 plus 5 is going to give us 2. Y equals half of x plus 5. So half of negative 2 is negative 1 plus 5 is going to give us 4. Then we've got y equals half of 0 plus 5. So half of 0 is 0 plus 5 is 5. Then we've got half of 2 plus 5. Half of 2 is 1 plus 5 is 6. So let's graph these values. We've got negative 6 and 2. We've got negative 2 and 4. We've got 0 and 5. And we've got 2 and 6. So negative 6 and 2. Negative 2 and 4. 0 and 5. 2 and 6. Great, we'll draw a line straight through them. Right here. And we'll label it y equals 1/2 x plus 5. All right. The last two examples are kind of special cases, and they're actually some of the easiest ones, but because they're a little bit different, they sometimes mess people up. So here, this one says y is 5. You notice there's no x over here. It's just y is 5. So no matter what x is, y is 5. I don't care what value you pick for x. It won't affect anything in this equation because there is no x there. So y is always 5. So if x is negative 2, y is 5. If x is 0, y is 5. If x is 1, y is 5. If x is 6, y is 5. So let's go to negative 2 and then look up at 5. It's going to be right here. And if x is 0, y is 5. And if x is 1, y is 5. And if x is 6, y is 5. So what we have here is a horizontal line where y equals 5. That's it. Now over here in this example, we have, let's see, let's pick black, sure. X equals 3. So no matter what y is, x is going to be 3. So you can pick any y values. Well, let's see what will y be when x is 3. Well, let's go with 2. And well, x is always 3, so if y is 0, x is 3. You can pick any values you want. It's going to always have x being 3. So if y is over here at, if x is 3, 1, 2, 3, y is 2. If x is 3, y is 0 in our example. If x is 3, y is negative 3. So we're going to go down 3. If x is 3, y is 4. So we're going to go over to 3 and up 4. So you'll see no matter what values you're picking for y, even if it was a decimal value in between or a halfway in between, x is always 3. So what we have is a straight line, a straight vertical line where x equals 3.